Hello students, this video is for class 8th, chapter 13, that is your electricity and circuit. This chapter we'll be doing in our physics notebook and let's start with this chapter. So as the name itself suggests, that is the electricity and circuits. Basically, we'll be studying about the concept of current, and we know as far as the current is concerned, it is nothing but the movement of charges from one location to the another location, and this bulk movement of charges is called as electricity. And the far path that through which the electric current flows basically is called as the circuit, right? And now moving on, the what we have understood or we have read in the previous classes, if we take up a basic circuit, right? So the we have two terminals from the battery. In the battery, that is the main source which generates the electric current. So there is a positive and the negative terminal. So current flows from the positive terminal of the battery to the negative terminal and through the external circuit, right? Now understanding, we have taken the direction itself only, like it goes from the positive to the negative terminal but through the external circuit. Now understanding, as I said, it's electric current is nothing but the movement of charges, and as far as we have studied that it is the negative charges that basically leave their position or travel from one point to the another, right? Now again, we have this topic electric current, and they have given a basic idea about the structure of an atom, and this thing we have again seen in the previous chapters of this class also. Like an atom, if we are considering, can be divided into two parts. First one is the central one, that is called as nucleus, and it contains two subatomic particles. Those are your neutrons and protons. Neutrons again are the one which are not having any sort of charge on them, and new protons are the one that have positive charge. And outside this, the nucleus, there are certain well defined orbits in which the electrons revolve, and they are the one basically which leave their places and are responsible for the current actually. Now as far as electrical conductivity is concerned, we all have studied these properties, like that something that conducts or that transmits or allows heat and current to flow from one point to the another, or allow to pass through them, sorry, are called as conductors. So conductivity can be defined in terms of electricity or in terms of heat also. And basically we have divided our basic general materials which we found in our surrounding in two categories, that they can be conductors or they can be insulators. One more thing is there, that is semiconductors, that we have discussed in class, and we'll be studying in higher classes also. So this year also we'll be studying about this property, that is conductivity, but we'll be focusing more on the electrical conductivity part. And let's start, right? So basically this content for this chapter starts from from a simple activity, like if we are having a battery and we have connected the two terminals of the battery with the help of two metal rods to a distilled water solution, and somehow in this circuit if we are joining a bulb also, we'll see that even though the circuit is complete, which it seems to be complete, but it won't the bulb won't glow. And the moment we add a pinch of salt, a little bit of it, and we stir up into that water, we'll see that the bulb will start glowing, right? That is what is given in the activity 2. So what happened is, like pure water, as we have studied in the previous classes also, is a insulator. Well, okay, it doesn't allow electricity to conduct through it, but the moment you add salt to it, so what happens actually is, like, the dissociation of ion occurs. So sodium chloride, that is a basic simple salt, gets split up into two ions. One are your positive and the other one are your negative ions, that is sodium ions and chloride ions. And these ions basically act as the carriers for the conductive for the electricity to pass through them. So like we have discussed about conductors and insulators generally in terms of solids, right? So coming to the point of liquids which allow electricity to pass through them are called as electrolytes, and the one which doesn't allow are called as non-electrolytes. Now again, basically impurities affecting electrical conductivity, we can say, like for example, if we say tap water or distilled water, so you have to understand the water is same only, but tap water basically means, you can say, something which has more amount of impurities. Impurities here I mean to say are the some of the soluble salts, like it might be magnesium sulfate, calcium chloride, calcium sulfate, or sodium chlorides, which might be dissolved, and they are the responsible for providing this electrical conductivity. Whereas the pure water, that is the distilled water, which contains only the molecules of water, are called as can be treated as a pure water. So the impure water, because of this dissociation of this compound into specific positive and negative ions, are called as uh, which are called as ions, right? Basically act as a good conductors of electricity. Now comes the topic of electrolysis. So, as the name itself suggests, electrolysis basically means lysis means splitting up, breaking up into two parts, and electrolysis basically means something we are breaking down with the help of electricity, right? We can understand this thing. Electrolysis, this chemical process, will be carried out in a specific setup that is called as electrolytic cell. And what do we mean by electrolytic cell is nothing that will be having a battery. From the battery, we'll be having two metal rods which will be dipped in a particular solution, and this entire setup is called as electrolyte. So again, basic idea is like the positive ions, like for example sodium, we said, is called as cation, and the negative ions are generally called as anions. So cations will generally approach this metal rod, which is called as cathode. So don't be get confused. Cathode is a negatively charged rod. Cations are positive, and cathode is something which is negatively charged. Similarly, if I am saying anions, those basically means it is a negatively charged ions, and they'll be approaching towards anode. That basically again means a road which will be having a positive charge. So what we have done doing this, when we are studying about this electrolysis in our syllabus, we are studying about electrolysis of water. So that is again, if we treat this, that water is again made up of two type of ions, that is your hydrogen ion and your hydroxide ions. So what happens is like, if we are adding a pinch of sulfuric acid, if we are adding a pinch of sulfuric acid, and we are able to pass out a strong current to that, we are able to collect hydrogen and oxygen gases. And the reason for that is like, if you check out, water is nothing but a compound which is made up of hydrogen and oxygen only, right? So when the setup is being done, we'll see that hydrogen ions basically will be formed at at the anode, or my mistake, it will be formed at the cathode, and the the oxygen gas will be formed at the anode, right? And now moving on to the next application is electroplating, that suggests that we have seen the simple applications. Some precious some object will be there, and we are trying to coat that object with some other metal with the help of again electricity, is called electrolysis. So in this in the book that we are studying, we have made a small correction, that is again in the diagram activity 5. So basically what we are doing is electroplating. We are going to understand with the help of an example. We have taken an iron nail and a copper strip, and we have taken copper sulfate solutions. So what need to be taken care of is like, iron nail is something that needs to be coated with copper, and the copper is being coated. So again, the solution of copper only we are taking. So what happens is like, the moment the current is passed through this electrolyte, basically the liquid which will be allowing the conductivity, so copper sulfate will get split up into copper and sulfate ions, and copper will start getting deposited on the iron nail, and sulfate ions will they'll start moving towards the copper strip. Again, this process is highly irreversible. If we change the polarity of the roads, okay, the entire process will be reversed up. So that's it from this chapter, guys. Thank you.